Hello and welcome to our Brownsville presentation representing DBN14. My name is Zanele Mkhize, and this is my team, Zamagcinengeyane, Phumelela, Mwelase, Spena Dube, and Spahlengid. And this is our content that we're going to be taking you through to representing our projects. And then we are so excited to guide you through to how we have transformed this innovative projects using Brownsville development approach, building upon an existing code base to create a dynamic, immersive experience. The Robot World project is a complex system that seamlessly integrates a central server managing the state of an evolving robot world, with clients who command and interact with their robots in real time. Our server ensures consistency across all the participants, while clients issues commands to control their robots, from moving and turning to launching and firing. The project operates on a structured communication protocol, leveraging SQL database for persistence and employing modern development practice, including Docker and CI/CD pipeline to ensure smooth integration and development by incorporating architectural patterns for modularity and scalability will enhance the system robust and flexibility. Software development source file. For version control, we've used the GitLab, which holds our software repository. This holds all of our source file separated into a different package depending on their purpose. This is the screenshot that we took to demonstrate all of that. Program specification. User stories were created based on how a user would interact with the program. Different scenarios were designed to ensure that software could handle a different interaction, as you can see. GitLab version control. The GitLab is used to prevent any loss of source files while performing on the projects. Separation and branches are created when working on a component. This then merged back into the main branch. Version control procedures with Git. Git is utilized to fetch and update the source file to make sure that the latest version of the file were used. Branches were integrated into the main branch before starting the new work. Any conflicts during merging were resolved locally using Git. The main documents. Documentation is available for each component and be referenced with user stories. The ReadMe file contains instructions to users to enable them to use the project to requirements. Thank you very much.
Hi there, my name is Phumelela Mwelase, and today I'll be walking you through how our project addresses key aspects such as data access, naming conventions, design documentation, testing strategies, and user compliance and documentation. So first, I think we'll talk about data access. Our program utilizes Web API for get and post methods. I'll give you a quick example of this. We've got a Web API already running. And in order to use a get method to get the current state of the world or to restore the current state of the world, we would just run the web address. And so for the current state of the world, you would see that the height is 1 and the width is 1. And for a restored state of the world, for a world that was previously saved, you'd see how that changes. Obviously, we're accessing a JSON object, interpreting a JSON object from a SQL database that we've already previously created. Now we can take a look at some of our naming conventions in our code. For example, there's a robot server class, which is responsible for managing robot communication, and a couple of other commands like the forward command, which is obviously self-explanatory too. This is to ensure that our naming practices are intuitive and easy to understand. moving on to design and documentation. We initially outlined a basic structure for handling certain commands, but a lot of them already came predefined because this is obviously a Brownfields project. Where there was some deviation was when we added new commands like path checker, which was to check whether there's a obstruction between where the robot is and where the robot would like to go. Obviously, this was just necessary for improving the functionality, and we've documented these changes along with the rationale. We've also done a couple of testing protocols. We've developed a comprehensive testing program. For instance, we performed stress testing by sending multiple launching commands simultaneously, which you would see here in our testing acceptance tests here. Launch mini test, where we would run a bunch of something like 9 robots into the world to see how the program responds to that. And our strategy involves a mix of unit tests and integration tests. For example, we test individual components, such as the forward command here in the movement test, and we test what happens if it reaches the west edge and the east edge, and so forth and so on. The strategy is tailored to cover all aspects of our projects. We meticulously record test results to monitor the performance and reliability of our system. For example, we use log files, which I think my colleague Spear has previously shown. And in terms of our compliance with user expectations, we ensure that the program responds quickly. So for example, I'll show you what happens if we run the client server. It's gonna work. So obviously the user will be able to quickly type something and immediately get a response back which is compliant with what they would expect. To facilitate user interaction with the software, we provide clear instructions. Users can start the program. Where's the ReadMe to demonstrate this? Users can start the program, start the server using a simple command, and issue robot commands via a REST API. And our documentation guides them through these steps to ensure that they can use the software effectively. For installation, we've created a Docker-based setup to minimize disruption. Users can install Docker, pull our image, and run the container with minimal configuration. Otherwise, they can pull the repo and run the repo just by running the ordinary Maven commands. Our documentation includes a detailed description of the program's purpose. It outlines how Robot World simulates robot commands and interactions within a virtual environment, providing a clear understanding of the robot's objectives and functionality. We also document the code layouts to give an overview of the program structure. For example, we explain that robot server Java manages communication, while path checker.java handles obstacle detection, and forward command.java executes movement commands. This layout helps in navigating and understanding the code base. To assist other programmers, we include comprehensive comments and documentation within the code. This documentation explains the purpose of each class and method, making it easier for developers to analyze and contribute to the project as they wish. Finally, our test documentation reflects the tests that can be run. Our test documentation reflects the tests that can be run and their purposes. For example, we document unit tests for the forward command class and stress tests for the server, providing insights into what each test covers and how it contributes to ensuring the program reliability. In this case, we obviously set up the server and make sure that the test works in accordance to the story and receives the results that we're looking for. Thank you so much for your time, and I'll be now passing on to my next colleague covering section C.
So I will be going over database management systems. Let's start with what a database management system, or DBMS, actually is. A DBMS is essentially a software that interacts with the end user, applications, and the database itself to capture and analyze data. The purpose of a database management system is to store, retrieve, and manage data efficiently. In today's digital world, data is one of the most valuable assets a company can have, and managing it properly is crucial for the success. Without a robust system in place, data can easily become disorganized, inconsistent, and even inaccessible, leading to numerous challenges. So these are the issues addressed by database management systems. We have data redundancy and inconsistency. So imagine a company where each department maintains its own customer data. Marketing, sales, and support teams all have separate records. This often results in redundant data, which is the same data stored multiple times, and worse, inconsistent data where the same customer might have different information across departments. This redundancy not only wastes storage but also makes it difficult to trust the accuracy of the data. There's also the issue of data integrity. Data integrity refers to maintaining and assuring the accuracy and consistency of data over its entire life cycle. So in our company example, if data entry errors occur in one department and not in the others, this leads to significant challenges in maintaining data integrity across the organization. There's also data security concerns. With the increasing amount of data being stored digitally, security is a top priority. Unauthorized access to sensitive data can lead to breaches that are not only costly, but can damage a company's reputation. Without a secure system, anyone could potentially access or modify important data without proper authorization. So there's also the issue of data accessibility. Accessibility is another critical issue. If data is stored across multiple platforms or locations, retrieving it can become a time-consuming task. For instance, if the support team needs to access data stored by the marketing department, they might face delays if there's no unified system. So an example, picture a scenario where a company struggles with inconsistent customer data across various departments. The marketing team has one set information while sales have another, leading to miscommunication and poor customer service. A DBMS can solve these by centralizing the data, ensuring consistency and accuracy across the board. So this is how a DBMS solves these issues. By centralization. So database management systems centralizes data, reducing redundancy by storing information in a single repository. This ensures that all departments access the same data, eliminating discrepancies. Centralization also simplifies data management as updates made in one place reflect across the entire system. With data integrity, data integrity is maintained through the use of primary and foreign keys. So these keys ensure that relationships between tables are preserved, preventing anomalies. For example, a primary key in a customer table ensures each customer is unique, while a foreign key in an orders table might link to that customer, ensuring that orders are correctly attributed. So for security, DBMSs implement strict access controls, ensuring that authorized users can access or modify data. This is critical for protecting sensitive information, such as financial records or personal customer details. For instance, the HR department might have access to the employee records, but only certain individuals should be able to modify salary information. For efficient retrieval, efficient data retrieval is another major advantage of using a DBMS. SQL is commonly used to perform complex queries quickly, allowing users to access specific data without needing to manually search through the entire database. This efficiency is crucial in a large-scale operation where time is of the essence. So, these are the key features of a commercial database management system. SQL support. SQL enables users to manipulate data with complex queries, making it possible to retrieve specific information quickly. For example, a business analyst might use SQL to find out how many sales were made in a particular region during the last quarter. Backup and recovery. Features protect data from loss due to unexpected events like hardware failures or cyber attacks. A robust DBMS ensures that data can be restored to its original state, minimizing downtime and loss of information. Transaction management ensures that all operations on the database are completed successfully and consistently. Concurrency control manages multiple users accessing the database simultaneously, preventing conflicts. So this is especially important in environments like banking systems where numerous transactions occur at the same time. So with database management system and user tools, the features include the fact that database management systems offer query builders, which allow non-technical users to interact with the database without writing code. So this is especially useful in business environments where decision makers need to extract data quickly without relying on IT. Data visualization tools such as Tableau are integrated with DBMS to turn raw data into insightful visual reports. So this allows businesses to make data-driven decisions by interpreting trends and patterns easily. So some limitations, but there's also some limitations involved. So these tools can be complex for beginners, and there might be limited customization options which could restrict advanced users. So a use case and example is, consider a business analyst who needs to extract sales data for a report. Using a query builder, they can easily retrieve the necessary data without writing any SQL code. They can then use the data visualization tools to prevent findings in an easily understandable format. So we have different types of DBMS and the examples that they use. We have relational database management systems. So an example of that is MySQL, which is best for structured data and transactions. It is widely used for applications requiring complex queries and transactions, such as banking systems where data is highly structured and relationships between entities are critical. We also have NoSQL, and MongoDB is an example of NoSQL database, ideal for handling unstructured large-scale data. It's used in scenarios like social media platforms where the data is diverse and doesn't fit neatly into data tables. There's also in-memory database management systems. So for our Robot Worlds project, we decided to use SQLite because it is lightweight and easy to use, and since it has embedded database, there is no need for a separate database server, and also because of our project requirements. So saving and restoring the state of a game world, SQLite's simplicity and ability to handle structured data like world dimensions and obstacles make it a practical choice. So now we are looking at database management systems in relation to our Brownfields project. So there are project-specific design and implementations. In our Brownfields project, the database management system is crucial for ensuring seamless storage, retrieval, and management of world and obstacles data. The objective here is to optimize the database design to support rapid access and ensuring that the game runs smoothly. So we have designed a worlds table to store attributes such as height, width, shield strength, and weapon reload delay, which are all critical for game logic. The obstacles table, on the other hand, stores details like type, position, size, and the associated world ID, ensuring that all the elements within the game are dynamically rendered during the gameplay, which makes it easier for the client. So this is how the database caters to our program's data needs. The worlds table captures each world dimensions and characteristics which are essential for gameplay. Meanwhile, the obstacles table ensures that obstacles are accurately retrieved and displayed during the gameplay, providing a dynamic and responsive environment for the player. When looking at third third normal form adherence. Our database adheres to the third normal form, which is a standard practice in database design to eliminate redundancy and ensure that data is logically stored. In the worlds table, each field depends solely on the primary key, ensuring no redundant data. Similarly, on the obstacles table, each obstacle is linked to a world ID without repeating groups or partial dependencies, maintaining a clean and efficient database structure. So looking at the key relationships between the tables, the relationships between the worlds table and the obstacles table is defined by primary and foreign keys. The primary key in the worlds table is the world ID, while the foreign key in the obstacles table links to the world ID, ensuring that each obstacle is correctly associated with its corresponding world ID. So primary and foreign key consistency. To ensure consistency, we have designed foreign key constraints that enforce relational integrity between the worlds and obstacles table. This guarantees that the database remains consistent and accurate even as data is updated or modified.
Good day, I am Usbahlengiti and I'll be taking you through Section D, Evaluating SQL Implementation and Data Management in Web Applications. I will take you through our database connection class, which is about evaluating SQL implementation. Our database class is a class that is for database connection to store and retrieve data for a Robot World games. It uses SQLite as a database management system. What it does, it creates two tables, world and obstacles if they don't already exist. It inserts world and obstacle data into the database. It converts world and obstacle data to a JSON format. It retrieves and prints all world and obstacle data from the database, and it restores world data from the database, including the obstacles. The code is designed to manage data for a Robot World game, allowing for the creation, storage, and retrieval of game, worlds, and obstacles. It uses basic SQL functionality, making the code easy to comprehend. Here are the following code snippets. This one is for creating the world tables. This one is for converting data to a JSON object. The next one is for restore world from the database, and this one is to insert the world. Next is data management in web applications. We have a class called Web API, which is in charge for data management in web application. In this class, it identifies methods for accessing data, particularly through the restore world from database method and Javelin API endpoints. The code showcases good data sharing practices using JSON objects within the application. It demonstrates the technologies linking a web server, Javelin, to a database, providing an example of a web server interacting with the database and serving data to clients. The code also illustrates method of linking web pages to back-end applications, particularly through the Javelin framework, which handles HTTP requests and interacts with the database. The API also serves on a specified port. It uses the port 5000. And here is our web API class, and this shows this code is for getting the JSON object, and this one is for connecting, linking the web application with the database, and this one is to restore from the database. Next, I will be demonstrating you the snippet of our code which has comments. Comments are to help you understand what part of the code is about. Thank you.
Good day, everyone. My name is Tiana Dube, and I will be doing section E, which is about assessing test plan execution and database access verification in computer program testing. Let us start with the tools we used for our tests. We used JUnit, we used Mockito, and we used Maven. JUnit Jupyter is the combination of the programming model and extension model for writing tests and extensions in JUnit 5. Apache Maven is a software project management and comprehension tool that we will demonstrate later on how we used to run all the tests in our program. And then also we used Mockito, which is a Java-based framework used for unit testing of Java applications. This mocking framework helps in the development of testable applications. In our test plan, we have an objective and the environment. The objective of the test plan is to verify the application's logic, to verify the database connection, and also to verify that the socket meets the communicating requirements. The environments that we used were Java, JUnit, Mockito, socket setup, etc. And then we also had something called continuous integration, which is our build pipelines that normally tested each and every commit that you made when you pushed work into GitLab. Now let us get into the presentation of our test. Let's go into this file called dump command test, which I'm going to show the logic behind on how we actually set up our tests and how they actually work. So when you look at the program here, we have a public class dump command test, which we are using Mockito, as I explained before, that it's one of the tools that we use to write our tests. So we used Mockito to actually mark the world and the values that we want to put in our dump command test. As you can also see that we have documented to explain what exactly happens in each and every method. Where, as you can see, before each, we set up the mock world object and mock behavior for the world to create a dump command instance. So I'm going to be explaining public void test dump with no robots and obstacles, where we already know that the expected output is that there will be no robots connected into the world. We first mark our world, we move on to dump command, and then we have a string expected output, which shows how we actually want the output to look like. So I'm going to run the test to show that it actually works. Okay, during the running of the test, you can actually see what happened. It's still building and loading our Maven dependencies. And as you can see, the test has passed, bringing back no robots connected and bringing back all the information that you can expect when you are running the dump command. So I'm going to run the whole package now to show the test logic part and demonstrate the standard of the unit tests that we have in our program. And this also refers to the retesting and testing to make sure that actually our packages and our tests make logical sense. Let me just run the test a bit and to show that each and every test that is inside the package is actually passing. In our program, we have both acceptance test and unit test. So now we managed to cover all the necessary tests and procedures thoroughly in our code. As you can see, there's a test for each and every command, and then we also have unit tests to show actually how our program is actually working. So to have all these necessary testing procedures, it gives us confidence that our development process and the quality of our software is actually good. So now I'm just going to run another package called client test, which posts and has most of our unit tests in it, which test for the commands that we have in our work. And as you can see, we have test pass of 16 out of 16. Now let's go into testing our database to demonstrate elimination of errors in our database access. So here we have our database save test, which is basically, as it says itself, it's to test that the roles can actually get saved into our database. As you can see, we have a before each and after each here. In the before each part, this is the setup of how we want our database to actually create the world. So we have a public void test save world 1, which, as you can see, it's a JSON object where we inputted all the values that are supposed to go into the columns in our database. Yes. And then we move closer to the after each. After each, it means that after each test is run, something needs to be dropped down. So here we are public void tearing down the tables that have existing into our database. So let's look into that. It will drop the table if it exists in world and drop table if it exists of the obstacles in our world. So now I'm going to run the test to show that the test is actually passing, the one that is to do with saving the world, saving world 1. And then I would like to run the whole file of database save test to show that actually our logic is working and all the tests pass in that package. There you go. As you can see, we have 3 out of 3 tests that are passing from it. Thank you. To verify that all our functions meet the necessary requirements, I'm now just going to run all the tests that are under our test file to show that all the tests that we have in our code are actually running. So let me just do this. Let me press acceptance test. We're going to run the test in our acceptance test. And this might take a bit of a while, but it's just to show you that all the logic that we have in our tests and all the things that we tested for are actually running in our program. So we're just going to have to wait a bit as we have some timestamps to allow our server to be able to be closed and open. And yeah, so let's just run a bit. As you can see, there are 20 tests under our acceptance test, and they're passing as we go. As you can see, sorry for the long delay, but like we had to make sure that we add some sleeper time so that it will give us enough time to close our socket before it goes to the next test. Yeah, we have 20 tests here, and they seem to be all passing quite well. This is exactly what we want to see when we're running our tests in our program, to literally verify that all the functions meet the necessary requirements. As you can see, it's going to show everything that it ran. This is the scripts that we get every time when we run our tests. Yeah. As I had said, in our program, we only had 2 different types of testing. We had acceptance testing and unit testing. So I also believe there is never such a thing as a perfect program. So I always know there's going to be improvements that we need to do when it comes to us testing. The least we can do is try to integrate systems testing and performance testing in our program. Systems testing is examining every component of an application to make sure that they work as a complete and unified whole. And then performance testing is the practice of evaluating how a system performs in terms of responsiveness and stability under a particular workload. I believe that according to the CITIC guidelines, we have met each and every goal that we were supposed to meet when it comes to our test execution in our programming. Thank you.